Well, I promised an integration video, so here we are doing the integration video. Although, of course, I kinda don't want to do this, but hey, a promise is a promise, so I won't go back on it. Of course, integration is a pretty annoying thing to explain, but bear with me for a little. I'll explain it. At its core, integration is the reverse process of differentiation, which we explored in the previous video. While differentiation breaks down functions into their rate of change, integration builds them up from their rate of change. Now, the way most teachers teach integration is through the Riemann sum, and it's a relatively simple definition of the integrals. And
wait, what am I supposed to say again?
Now, this is what the Riemann sum actually looks like in math terms, and I know that this is really confusing, but you don't really have to understand all of it. Essentially, what we are doing here is that we are dividing the graph into equal columns, and the rectangular columns touch the graph at points, and only those points either on the left or the right side. Now, note that the approximation is very rough for small values of n, but it does get better as n approaches infinity. And then after that, it's your job to add up the area of all the bars. Spoiler alert, no one wants to do that. But as we all know, the integration is just the opposite of differentiation, so you can apply the power rule of differentiation over here as well, just in reverse. Of course, this rule is carried over as well, but it is pretty simple and straightforward, so I won't waste your time on this. Also, here are the trig functions, and yeah, these are very confusing, and don't ask me how they are derived because honestly, I have no idea either, but the exam won't test you on the deriving of any of this, so don't worry about that. By the way, have you noticed how there's a c here, but not here? Well, the reasoning for this is that there are two types of integrals, indefinite integrals and definite integrals. Indefinite integrals have a c because, well, they're indefinite and there's a constant term, but definite integrals do not require a c because the c will eventually cancel out. But now you may ask, how do I tell if the integral is indefinite or definite? Well, if you see anything on the ends of the integration symbol, then it's a definite integral.